Okay, now we're going to look at a different type of a discrete probability distribution, to a specific one called the binomial probability distribution. And there's some criteria for the binomial probability distribution, and you have two possible outcomes. You either have success or failure. And so now your random variable represents the number of successes. The other criteria is that the trials are independent. And also the probability is the same in each trial. And those two things kind of go together. When they're independent, their probability is going to be the same in each trial. And lastly, you're going to have a fixed number of trials. So here's how it works. Let's go with an example. Say you have Jason Tatum. He's a player for the Boston Celtics. And let's say that his free throw percentage is 80%. I think it's a little bit higher, but let's use 0.8 as a nice place to start. Let's say in a game, he takes 10 free throw shots. What's the probability he makes 10 of 10? Now remember, this is difficult to compute all at once, right? But what's the probability that he makes one of them is going to be 0.8, right?
Yes.
And then the second one, what's the probability he's going to make that one?
It's 0.8 by 0.8, right?
It's going to be 0.8 again. Now technically, that free throw percentage is going to change every single time by a slim margin. And the reason is because he has more trials and more successes. However, we're going to use the cumbersome rule for large calculations, and we're going to treat these trials as independent. So the first one is 0.8. The second one is 0.8. The third one is 0.8. And really what you're doing here is you're multiplying 0.8 times 0.8 all the way to 0.8, and you're going to do that 10 times. So you're actually just going to do 0.8 to the 10th. So he has about an 11% chance of making 10 of 10. You all with me on that? That makes sense, right?
Yeah.
Now, what is the probability of getting 9 of 10? And this is where it becomes a little bit more difficult, right? Because let's actually think about what's happening here. He's going to make 9 of them. And he's going to have to miss one of them. Because his probability of missing is 0.2. And his probability of making it is 0.8. But we also have to figure out all of the possible ways that he can make 9 out of 10. If we think about it, we go right back to what we learned last class when we talked about combinations and permutations. If he has 9 successes, and 1 failure, that is one possible way that he can make 9 of them and then miss 1 of them. But we want to figure out how many different ways we can rearrange that. And we need to multiply that using our fundamental counting principle by the probabilities that we are assigning to the 9 that he makes and the 1 that he misses. So remember, to figure out all of this, we're doing 10, choose 9. Because really this is 10 factorial divided by 10 actually no, 10 minus 1 factorial. So we're just going to do 10, choose 9. So we do 10, choose 9, which is 10, times 0.8 to the 9th, times 0.2 to the 1st. Oh. 10 times 0.8 to the 9th times 0.2. And that probability is going to be 0.2684.